Good morning, students. Today I am going to explain about multi-layer perceptron. Multi-layer perceptron in machine learning. It is a one type of artificial neural network. It is made up of with multi-layer neuron nodes, multi-layer perceptron. Multi-layer perceptron in ML. Mainly, this multi-layer perceptron is used in. It is a one type of artificial neural network. ANN means artificial neural network. Artificial neural network. This multi-layer process is called as a backpropagation. Mainly, it is used to in this multi-layer perceptron. We have three layers are there. First one is input layer. Next one is hidden layer. Next one is output layer. Mainly, this multi-layer perceptron is used to both classification and regression. The main mechanism of this multi-layer perceptron is forward propagation, backward propagation. In this forward propagation, again we have three steps are there. So in this input layer, we have input data. Hidden layers are input layers, and in between the hidden layers are available in between the input layer and output layer. Input layer and output layer. Output layer provides the final result. This is all about multi-layer perceptron layers. In this we have three layers are there. So how now I'll give the representation of multi-layer perceptron. How the multi-layer perceptron is representing. I'm writing here representation of MLP. In shortcut, I'm writing students. Multi-layer perceptron. These are the input layers. Here I'm drawing a sample diagram. These are the input layers. Next, these are the hidden layers. These are the output layers. This is the sample diagram for, and also each and every neuron. These OLs are considered as a. I'm writing here. It is a input. It is a input neuron. These are called as a neurons. Each and every input neuron connected is connected to the hidden layer. Okay, each and every input layer is connected to the hidden layer. And also hidden layer is also connected to the output layer. The first one are the input layers. I'm example I'm taking as the three input layers. Here, your wish, you can take any number of input layers and any number of hidden layers and any number of output layers. Okay, na? Input layer. Next one is output layer. Okay, this is all about multi-layer representation. Now I'm going to explain about forward propagation and backward propagation in multi-layer perceptron. We need to follow some rules here in forward propagation. First, I am explaining the forward propagation. Both forward propagation and backward propagation. First, we'll do for forward propagation. Mainly, this multi-layer perceptron is used to re reduce the errors in the output. First step in forward propagation, here we need forward propagation in three steps. First step is step 1. First one is calculate input and output in the input layer. Input and output in the input layer. Sorry, ma. Next, in this input layer, it is a direct transfer function where output of the node is equal to the input, where output of the node is equal to the output of the node is equal to the input layer. I'll explain with example here. First, I'm discussing about the steps in forward propagation and backward propagation, where output of the node is equal to the input layer. Ij, capital Ij equal to the xj. This is Ij equal to the xj. This is the first step where j is the where xj is the input received at, where xj is the input received at node j. Okay, input received at node j. Next, okay, na xj is the input received at node j. Output is equal to the input in this step 1. Coming to the step 2. In step 2, calculate net input and output in the hidden layers. Calculate net input and output in the hidden layer. First, we are finding for input layers. Here we have 3 layers are there. First one is input layer, second one is hidden layer, third one is output layer. First, we are in this, we are calculating the input and output in input layer. In second step, calculate the net input and output in the hidden layer and output layer. Okay, no? The formula for this how to calculate the net input and output for the hidden layer and output layer is, first for I am writing here, it is output layer, hidden layer. Okay, na? Next for output layer. Here we are calculating both input and outputs for the hidden and output layer. So here I am writing for first hidden layer. It is for hidden layer formula. Ij equal to summation of I equal to 1 to n oi, o means a output, wij plus x naught into j plus x naught into theta j. Okay, this is for the hidden layer formula. In this, where oi is the output from node I, where oi is the output from node I, Wij is the weight in the link from node I to node J. Wij is the weight in the link from node I to node J. Wij is nothing but weights. Here we are randomly we are assigning the weights in a input layer to the hidden layer and in hidden layer to the output layer. The weights are always in between 0.5 only, minus 0.5 to plus 0.5. And also here we have x naught and theta j are there. X naught is a input to bias node O. Input to bias node O, which is always assumed as 1. The bias is always assumed as 1 only, which is always assumed as 1. Bias is always 1 in all in this problem, in every problem. Next one is theta j. Theta j is the bias node 0 to node j. Okay, na? It is the input to x naught is the input to the bias node O. Theta is the weight in the link. It is a weight. Weight in the link from the bias node 0 to node j. Okay, this is the second step. First one is the ij equal to ij. This is the first formula. Next one is the this is the second formula for hidden layer only. Now in step 2 I am writing the uh, for output layer formula. Calculating the both input and output in the hidden layer, right? It is for hidden layer only. This formula is for only hidden layer. Next, how to calculate the input and output for the output layer? Output at node J. Output at node J. Next, this formula is Oj is the output 1 by 1 plus e to the power of minus, it is minus ij ma. Okay, no? Minus ij. This is for output for both hidden layer and output layer. Here I is the input received at node J. Here I is there, na? Capital I is the where I is the input received at node J. Node J. Up to here, two steps in forward propagation, and also we need to calculate the third step. Estimate the error rate. Next, third one is estimating the error. This is the step 3 in forward propagation only. This is the step 3 in forward propagation. In forward propagation, estimating the error at node 3. At last, we are finding the estimating the error. How much error happens? Okay, estimate error at node in the output layer. The formula for this estimating the error is error equal to O desired minus O estimated. O desired will give it in problem only, ma, example problem, and O estimated is our output in the second step. Second step we are finding the output, right? That is the O estimated. Next, O desired is nothing but the output value of the node in the where. Here I am writing the what is O desired and O output estimated. Okay, na? Where O desired is output value of the node in the output layer. Output value of the node in the output layer. Next, O estimated is the estimated output value of the node in the output value. Estimated output value. Estimated output value in the output layer. Okay. This is the third step up to forward propagation. Next, I'm explaining the backward propagation. In backward propagation also we have two steps are there. First step is calculate error at each node. Why we are doing backward propagation means after finding the forward propagation error, if it is need, we are doing the error is more, we are doing the backward propagation to reduce the errors. Okay, backward propagation. In backward propagation we have, sorry ma, it is backward propagation. Backward propagation. In backward propagation again we are calculating error at each node. In forward propagation we calculate error at output node only. In this backward propagation we are calculating the error at each node. Calculate calculate error at each node. Okay na? In this also we need to follow some formulas. The formulas are the, for each unit K in the output layer, K in the output layer, error K equal to, error K equal to OK means output layer K 1 minus OK into O desired minus OK. Yes, OK. Okay, no? Where OK is the output value at node K, where OK is the output value at node K, okay, in output layer, in output layer. Okay, na? Next, O desired, just now we discussed the O desired, right? O desired is the output value node in the output layer. O desired is the output value of the node in the output value of the node in the output layer. This is the first step. Again we are finding the error at each node in backward propagation. And next, for each this is for each unit. No, in this also again we have two formulas are there. For it is for output layer, and also we are finding the error for the hidden layer. Clear? So in for output layer we are taking element as K. For hidden layer I'm taking element as j. Okay na? In this calculate error at each node we have again two formulas are there. For each we need to find out the error in two, output layer and hidden layer. Here I am taking k as a element as output layer. Next j is the, for each unit j is the input layer. J in the hidden layer. Next, do formula for to find out the error in the hidden layer is error j equal to oj into 1 minus oj summation of k error k w jk. W means weight. Okay, na? New weights, where oj is the output value of j in hidden layer. oj is the, what is okay ma? oj is, ok is the output value of the k in the output layer. Here oj is the output value of the j in the hidden layer. Hidden layer. Next one is the error k. In this error k is the error at node k in the output layer. Error, just now we have seen in this error k, right? For our output layer it is okay na? Same, what is error k value we are getting here, same that error k is we are using here. Error k, error k is the error at node k in the output layer. In the output layer, this is the first step in backward propagation to find out the errors in each node for output layer and for hidden layer. In next step we are updating the weights and bias of the calculated errors and all. Okay na? Next, step 2 backward propagation, update all weights and bias. Update all weights and bias. First, how to update the weights here? How to update the weights? Update weights here. Update weights delta, this is the weight ma. Update weights equal to alpha is a learning rate. Okay na? In give problem only they'll give the learning rate alpha. Error j into oi ma, input. Oi is the output value of node I. Next, w ij equal to wij plus delta wij. These are the two formulas to find out the update weights. Okay na? Next one, where what are the terms of oi oj error j wij? So I'm clearly explaining here. Oi is the output value of node a, node j, output value of node I it is. Next one is error j, here it is right. So error j is the error at node j. Error j is the error at node j. node J. Next one is the alpha is the learning rate. In given problem, they will give the learning rate. Learning rate is always less than 1 only. It is 0 0.1, 0 0.2 like that up to 0 0.9 and 1. Okay. Na? Next, Wij is the weight in the link from node I to node J. Delta Wij is the difference between the weights that has been added to Wij. Okay, I'll write here. Okay, na? Wij. What is Wij? Wij is the weight in the link. Weight in the link from node I to node J. From node I to node J. Next, delta Wij. Delta Wij is the difference in weights that has been added to Wij. Difference in weights that has to be added to Wij. Okay, na? This is about how to update the weights. Next one is update bias. Okay, na? Update bias. A bias is always in just now I'll told you bias is nothing but theta, denoted as theta. The formula for find out the bias is delta theta j equal to alpha into delta theta j equal to alpha into error. Previous error. Error means previous error how much you got. Next, theta j is the theta j plus delta theta j. This is the delta plus delta theta j. This is all about update bias. Next one, theta j, here error j is the error at node j. It is error at node j. It is error j. Error j is the error at node j. Alpha is the learning rate. Next one is theta is the bias value. Theta j is the bias value from node O to node j. Bias value from node O to node j. Next one is theta delta j is the difference in bias that has to be added to theta j. Theta delta theta j is the difference in bias that has to be added to theta j. That has to be added to theta j. This is all about the multi-layer perceptron. No? Once again, I am repeating the multi-layer perceptron. It is a one type of feed neural network with multiple neurons are arranged in a network layer. Okay, na? Multiple neurons are arranged in a inputs. Multiple neurons arranged in a inputs. Okay, na? This is all about the input layer. Multiple neurons are arranged. Here, example I am taking it is x1, x2, x3. These are the x3. These are the input layers. This is the hidden layer. This is the output layer. And also here the main thing is at least we have input layers in 3 layers and one or more hidden layers and one or more output layers. Input layer is always a visible layer. Hidden layer is in between the input layer and output layer. Output layer gives the final value. Okay, no? Next, coming to the in this output layer, in this multi-layer perceptron, we have both forward propagation and backward propagation. We are using forward propagation means we are calculating the error, how much you got in this. Okay, no? This is multi-layer perceptron is used in both classification and regression. For two steps are there. First, we need to find out the propagation. After find out the error in forward propagation, if it is less than 0.1, no need of calculating the backward propagation. If it is 0 above the 0.1, no need means I'm exactly not saying it is no need. If you want to wish to continue do the backward propagation, you can do. Otherwise, it is 0.009 means it is less error. So you can your wish if you want to find out the error backward propagation. In backward propagation, we are reducing the errors. So for that calculating the error, how much it is in given problem. So first we are for calculating the forward propagation. In forward propagation, we have 3 steps. Ma. First one is calculate input and output layer in the input layer, input and output in the input layer. The formula for this input and output is ij equal to xj. Both are equal in this. Next, calculating the input and output in the hidden and output layer. This is the formula for the ij. Okay, na? This is the formula for the uh, hidden layer, calculating the input and output for the hidden layer. Okay, next coming to here, it is the calculating the output oj equal to 1 by 1 plus e to the power of minus ij. In third step, we are find outing the estimated error at node in the output layer. For that estimating the error, finding the error, we are following the O desired minus O estimated. O desired value always we will take as 1. Okay. In given problem, they will give now 1. What is the what is the desired value? How much you are expecting? This is the estimated value. In next one is forward backward propagation. After finding the error, if it is more, if you want to reduce that error, again you can do the backward propagation. In this backward propagation, first one is calculating error at each node. In that again we are finding the each unit k in the output layer and each unit j in the hidden layer. The formula for the output layer is error k equal to ok into 1 minus ok, O desired minus OK. Next in this again we have find out the output layer, and this is for formula for output layer. This is formula for hidden layer. Error j oj 1 minus oj. This is the formula for the hidden layer. Clear? This is the backward propagation in step 1. In step 2, we are updating the bias and weights. After calculating the all errors and updating the, we are finding the, we are updating the weights and bias. This is the calculating for weights. This is for updating the bias. Okay, ma? This is all about multi-layer perceptron, how the multi-layer perceptron will work, how the input layers, output layers and hidden layers. Clear? This is all about multi-layer perceptron. Thank you.